attending this meeting, this case study. I would say fair competition, because this is a competition that is of benefits for all the industry, because from any case study that is provided by our corporate members, there is something that uh, all the engineers, consultants, manufacturers can learn about potential of applications of geosynthetics. Today we are going to introduce four players. The corporate members are ACE Geosynthetics, and the presenter will be Arnold Kiptum. Macaferri with Jay, Yusker with Matthew Howard, and TechFab with Manish Bharat. Each of them will present some of the projects that they have made in the last 2 years in Africa or in Middle East. Of course, I say that it is a fair competition, but of course there will be a winner, and the winner will be indicated by the judges, that today are Mohamed Salah Morsi from IGS Egypt, Associate Professor of Geotechnical Engineering at Ain Shams University in Cairo. There will be Charles Cilliers from IGS South Africa, a professional engineer and owner of Liner Works, specialized in geosynthetics and civil engineering consultancy. And Viviana Mangraviti, who is also chair of the Young Members Committee and belonging to IGS Italy. She's a researcher in geotechnics at the University of Padova, and the Department of Civil, Environmental, and Architectural Engineering. Thanks to all of the judges for accepting the invitation to review the papers and now the presentation, so that by then they can provide the score and determine the winner. The winner will by then be invited to present again his case study at the special session that we will have in Montreal at the International Conference on Geosynthetics, where the international winner will be selected from the 4 IGS regions, because before this session, also there has been a winner in Geo America in April 2024, where Yusker was the winner with a project where polyester geogrids high tenacity were used for to repair a bridge collapsed in USA, in Philadelphia, on the Interstate 95. Very critical projects. And by using the geogrids, was possible to reconstruct the bridge wall in a very record time of 12 days. So example of application where cost and time saving have been recognized to the application of geosynthetics. In Brisbane, last July in 2025, Macaferri has been the winner with a railway project in India, where the geogrids have been used for reinforced soil embankment of very steep slopes to minimize land use, and by reusing the same soil as structural soil from the excavation of the tunnels. A great example of sustainability with a reduction of carbon emission and a gain of overall costs. Finally, last September in Lille, Solmax has been awarded with the supply and installation of tailored geosynthetic solution to create the Germany's first PTS site, where the works is the characterization is that there is a sort of reservoir for heated water to a maximum of 90 degrees. So again, the possibility to provide a tailored solution and challenge to extreme conditions and durability of geosynthetics. Let's see today who is going to be the winner. And we start with the first presentation from IGS Geosynthetics. And the project is mechanically stabilized earthwall for bridge ramps in Nigeria. And the presenter is Arnold Kiptum. Please, Arnold. Let's share the video.
Yeah. Thank you, Mr. Angelo. So let me just share my screen in a moment and begin the presentation.
Perfect.
Okay, just a second. Okay, so let's begin with the presentation. Yeah. Okay, so to the presenters and to the audience members, thank you so much for making the time to attend this presentation and the organizers for arranging the presentation. So I'll begin to explain this case study presentation. It was carried out in Lagos, Nigeria, titled "The Mechanically Stabilized Earthwalls for Bridge Ramps in Nigeria." So let's begin. So let's begin with the project background, where we see the history of the project as well as the challenges that are faced in terms of executing the project, as well as the inception phase of the project. So as a background, this project was initiated by the Lagos State government. It was mainly to enhance the interconnectivity of the Lagos Rail Mass Transit Red Line development. So for this project, particularly, it took place in Yaba, as you can see in the screen. And the red line you can see also in the picture is the red line, which is a railway network around the Lagos area. Other key objectives of this project was mainly to connect the key roads along the red line network, manage high traffic within this location, as well as address the safety and traffic congestion around the points where the rail and road intersect within the sections, within the project sections. In terms of the main challenges of the project, we have three main problems: cost constraints, time constraints, as well as space constraints. There was a limited budget, mainly due to the ongoing project, other sections within the Lagos Rail Mass Transit Red Line Development Project. So a budget had to be contained properly in order to ensure that the overall development was successful. In terms of time constraints, the commissioning of the project was to happen within 10 months due to election cycles, and this commonly affects projects within the region. And lastly, in terms of the space constraints, there was a huge priority in terms of minimizing the amount of land that was used for the project, as well as to allow for rail operations to continue within the area. As you can see in the picture on the right-hand side, the area is quite dense, and therefore this was one of the constraints that we had for this project. So looking at design and construction of the ramps. So this picture on the screen shows an overview of the project. Note the railway line in red color passing under the bridge, as well as the three bridge ramps at either side. So we do have one, the longest one, spanning at 151 meters, connecting the Ojo-Elegba Road. Then we do have two along the Murtala Mohammed Road, which span 146 meters and 134 meters. So, and these bridge ramps went to a maximum height of 7.5 meters, as listed on the screen on the right. Looking at the section of the wall had three main components, namely the MSC wall, a unique anchorage system, as well as the precast full height panels. So to note, for the MSC wall, it was chosen mainly to save on the construction footprint due to the limited space. There's also a need to mitigate the differential settlement around the site, since there was some bit of loose soil, and also to allow for lower material costs, since cost was a huge part of the project. Looking at the precast full height panels, this was crucial because through the anchorage system, we were able to ensure that there was no direct concrete grouting into the MSC walls, and also in the event of accidents or incidences within the area, these full height precast panels will be able to allow for impact protection of this structure. So on the screen, we do have a detail of the anchor bar and the anchorage system that was used to connect the facing panels to the MSC ramps in all the three sections. So this was mainly done to manage the differential settlements between the MSC ramp as well as the facing panels, and also address the durability challenges that would occur in the event where we have geosynthetic materials directly embedded into concrete units. So looking at the benefits and contributions of geosynthetics materials in this project, we have quite a few. And starting with environmental conditions, locally available materials were used for this project. For this case in Lagos, it's sand, and therefore this material is easily obtainable within the site, and this made for a good use for the backfill. Also, since thinner panels were used for the facing and only at the coping section, the use of concrete was really reduced, and this helped also in the cost aspect. Looking at the environmental contributions of the projects, now if we compare in Nigeria and the use of MSC walls, commonly in Lagos, Nigeria, RC bridge pier ramps are the most widely implemented structure due to for quite a long time. And therefore, we were able to compare that by using the precast facing ramps, we were able to provide carbon emission savings of 74% compared to this typically used RC bridge pier ramps. So the graph on your left also shows the percentage reduction for the RC bridge pier ramps, the cantilever retaining wall that we also thought would be an option, as well as the CIP facing and the precast facing ramp, only producing emissions of 406 tons of carbon emission. That is, and for this analysis, the main criteria was mainly around material production and transportation, as shown on the screen. Also, in terms of other economic contributions, were that because of less concrete use and other materials as well, we were able to estimate material savings of 55% as compared to RC bridge pier ramps. And because the project only took 7 months, this provided also additional cost savings by avoiding project overruns that are common with most projects within the region. In terms of construction efficiency, the MSC ramps also allowed for construction to take place in a limited amount of space. In the previous slides, we were able to see how dense the area was. And also, when you look at in terms of maintenance, because MSC structures also allow for low intensity and low frequency of maintenance, this helps to reduce the long-term costs of spending in maintaining infrastructure facilities, particularly in the public sector, or public use. So also, we were able to identify some social contributions of the project, and we have 3 main ones. Since the construction of MSC ramps is less intensive, it produces less noise, vibration, and therefore the community around there is disturbed. So in the previous slides, we were able to note that the area was within a market area. There was also a bus transit station around the area, as well as a health institution and a technology college for people in the area. So this was a huge contribution to their well-being. Also, looking at the aspect of the construction of the ramps, we were able to have a few students and graduate students as well, interns and students, and this provided a platform for skill transfer and capacity building for these students. And because the construction footprint was minimized, economic activities, particularly in the market area, were not disrupted. So all these contributions also helped to align with SDG principles, such as the 3rd, 8th, and 9th and 11th as well, as listed in the top of the screen. So this shows some contributions of this project towards sustainability goals that we have. So as we wind down to the conclusion, we do have a video summary of the project to help you appreciate the construction phase of the project, as well as understand the impact that this project was able to make to the society within the area. So hope you enjoy. Yes, and that, ladies and gentlemen, is a completed structure. As you can see on your left, this structure was able to contribute greatly to the society, to the community around the area. To your left, you could actually see how much the infrastructure has changed the area around it and how it has really enhanced mobility with the trains, with the bus station, with the traffic, and everybody trying to get into the market and the various institutions around the area. So other than that, thank you to the organizers and to the audience members for having listened to this presentation. So thank you. And I think I would like to welcome any questions or if there's any comments from the panelists. Thank you so much.
Thank you, Arnold. I forgot to say before that the time restriction for the presentation is of 12 minutes for every presenter, and we were in these 12 minutes, and now there are 3 minutes of a question and answer that can be given by the judges, and the attendants instead can write in the chat any question that eventually by then, if there is time, can be answered. Thank you. Professor Morsi, I see that you're ready.
Yes, so I just have like an inquiry. What was like the clearance between the reinforced soil and the concrete facing panel?
Okay.
The horizontal distance between the...
Good question.
Okay. So between the MSC wall and the precast panel, we had a gap of 150 millimeters in between.
Yes. And so did you calculate the post-construction movement of the MSE wall?
So during the construction phase, since the panels, what
Cannot hear you. I cannot hear. I don't know.
Yes, I cannot.
Yeah, we can't hear.
Okay, now it's okay. Arnold?
Okay, so I was mentioning we were not able to calculate any post-settlement movement. However, the design philosophy was that since the panels are going to be connected after the structure has already finished any sort of movement that would have happened, we were able to ensure that during installation, no movement was had happened and that the structure was at its limits at that point.
Yes, but did you double check the movement using the chart in the FHWA, like relating the reinforcement length to the wall height with the anticipated lateral movement?
Okay, yes. So we were able to estimate the movements and all the settlements were able to be verified. So upon inspection after the site visit, after the structure was completed, there weren't any cracks or visible signs of movement with the structure.
Okay, thank you.
Any other question? Perfect.
Yes, just one question. Maybe I missed it, but was there any reference to a design code for the engineering of and the stability analysis of the MSE structures?
Yes, the structure was designed according to FHWA manuals, volume 24 and 25, respectively.
Yes, I have a kind of similar question about the material used. Were there materials in ISO standard or ISTM standard? Maybe I missed that as well.
Yes, all the materials were verified by the project consultant that they were applicable with the standards, the STM standards, before the construction phase began.
Thank you.
Very good. We are on time. So thank you very much, Arnold, for your presentation that is showing the versatility of geosynthetics that can be easily applied also when where there are poor soil and can guarantee cost and time reduction in the execution without disturbing the life in the surrounding, let's say. So not affecting the traffic congestion as in this case.
Thank you as well.
Next presenter from Macaferri, Jay from Dubai. The project name is Transformative Geosynthetic Application in the Guinness World Record Holders Doha Expo House 2023, project in Qatar. Prego. Sharing the, very good.
I hope you can see my screen.
12 minutes to go. Prego.
So, good morning, good afternoon, and good evening to all of you tuning in from different parts of the world. Ladies and gentlemen, it is my pleasure to present to you the transformative geosynthetic applications in the Guinness World Record Holder Doha Expo 2023 project in Qatar. Now, when I say this, I truly mean the way in which geosynthetic solutions played a transformative role in delivering the project's green desert vision that you will see in the next slides. Let me take you through the general background of the challenges associated with the projects like this in the Middle East and how geosynthetics can contribute to solve them to some extent. You know that Middle East faces the severest challenge of desertification and land degradation due to different factors such as climate change, fast development happening here, and fragile ecosystem which is already existing. Now, the Doha Expo 2023 project, as you can see in the master plan, embraced the theme Green Desert, Better Environment, proving that desert landscapes can be reshaped into sustainable green spaces, as you already see in the master plan. Now, the Expo House building is a landmark in the whole project, since it showcases how architecture, landscaping, and sustainability can integrate to perform in harsh desert conditions, highlighted by its green roof, as you can see here in the architectural rendering already, as well as the vegetated slopes. Now, what can be the role of geosynthetics in this? They can be used for the creation of steep vegetated slopes, efficient water management, and reduced material used to support sustainable development in arid regions. Now, coming to the Doha Expo project itself. This was the first ever horticultural expo in the whole Middle East and North Africa region, and it ran for 6 months in Al Bida Park in Qatar, all centered on the sustainable landscaping in arid climates. The event projected the Expo House building as the main landmark. The structure has a semicircular shape, opening into a plaza and an amphitheater, and it fits perfectly with the whole green desert theme. The design uses, here is the completed project. It uses a green roof and a landscaped slopes to show what modern planting systems can be actually work in desert conditions. So it's meant to be practical, but it's also a live demonstration of how, how these things can be made possible in the desert condition or in the arid climate. You can see, you can have a comparison between the completed structure and the previously shown rendering, how it has a striking similarity. Now, role of geosynthetics, making steep vegetated slopes in Doha is not simple. We need proper soil retention, drainage, and plantation support. And that's what exactly where geosynthetics made the idea of the architect buildable. Let's have a look at how geosynthetics were actually used in the project. Here you can see a cross-section of the earth mount. We have to support vegetation in a very dry climate, reinforce tall slope, and still reuse the site soil which is poorly graded, which is the dune sand. So the system needed to be strong and environmentally efficient. The steep external reinforced soil slopes went up to 14-meter height. We used a combination of MSC green slopes, geogrids, geomats, square geomat, non-woven geotextile, and steel brackets to manage the changing angles. Whereas the inner gentle slope, the slope angle varied from 23 to 35 degrees. And here the visitors are expected to walk. So we used some shorter geogrids and geocells for stabilization and soil confinement with the help of J-hooks, and a coir geomat layer was provided all over on the top for the erosion control. Below the entire footprint of the green mount, a layer of drainage geocomposite was used with a geotextile on the top and a waterproofing membrane below, which allows the recirculation of the excess irrigation water and preventing any ingress of water into the structural soil. And this is how we were able to use the dune sand as the backfill soil. rather than importing engineered fill, because dune sand, the problem is that it looks compacted, but when it comes in contact with water, it further settles and it can cause bulging of the structure. So as a result, all the geosynthetics worked together to deliver the geometry, stability, and sustainability that the project needed. So here is a quick summary of the geosynthetics used in the project: geomats, non-woven geotextiles, drainage geocomposites, geocell, and MSC green slopes, serving the function of erosion control, separation and filtration, drainage and waterproofing, retention of cover soil, and soil reinforcement for steep slopes. Let's have a look at the construction sequence, which is bifurcated into the inner gentle slope and outer steep slope. So here you can see the inner gentle slope. During construction, the geocell laid with a close view, a distant view, and here is the completed inner slope, gentle slope with vegetation grown. Here, this is a close view of the outer steep slope. During construction, a distant view. And here is the outer steep slope after construction with vegetation grown. This is another view, a distant view from the roadside after complete greenery has happened. And this is another view from the inside, from the amphitheater side, the beautiful expo house build completed with greeneries. Now, let me walk you through how the project was recognized and the broader impacts we have created. The project was successfully completed in 2023, and it was delivered exactly as planned for the international exhibition, meeting all design, functional, and sustainability expectations. The Expo House quickly became the most photographed and most visited attraction of the 6 months long horticultural exposition, giving the project exceptional public visibility and recognition. And here comes the most important thing. The end client, Ashgal, received an official Guinness World title for the largest green roof, having an area of 4,031 square meters in September 2023, giving the project a global recognition and credibility. Needless to say, the geosynthetic-based solutions also contributed. It provided stability, drainage efficiency, and vegetation support needed for the green slopes to perform in harsh desert conditions. Let me take you through the sustainability comparative studies. We have studied 2 scenarios because at one point of time, it was really required for imported fill, and that apprehension of the project stakeholders was solved by the provision of a drainage geocomposite all around. So here we are comparing 2 scenarios, case A with drainage geocomposite and site 1 dune sand as the structural fill, and case B with a non-woven geotextile separation layer and imported engineered fill. So in case B, about 24,500 meter cube of engineered fill would be needed to be mined, processed, and hauled. And that transport alone drives significant emissions and energy use. So this forms the basis of the life cycle assessment, these 2 contracting approaches, reuse versus import. And that formed the basis of the comparative life cycle assessment. And you can see the results with reference to the 7 most important environmental impact categories. So here you can see the results are very clear. Case A, the solution using site 1 soil with the drainage geocomposite performs better in every single impact category, whether it is global warming potential, fossil fuel depletion, particulate matter emission, or ecotoxicity. And case A consistently shows lower environmental impact. So the geosynthetic enabled reuse of soil directly translate into measurable sustainable gains in the range of 73 to 37%, as you can see from the normalized representation in the graph here. Sustainability doesn't stop here. Let's see how the Expo House stands out as a project sustainability flagship. The Sustainability Progress Report from GeoRD, which means Gulf Organization for Research and Development, presented the Expo House as the benchmark for sustainable design across the whole 1.7 million square meters of Expo site. So here you can see in the reports, 4 pages are dedicated to the Expo House, and it shows it is featured as the most prominent sustainability enabler in the whole project. Expo House is the only structure in the whole project that achieved the GSA's 4-star rating, which is why it is featured so prominently in the sustainability documentation. So GSAS stands for Global Sustainability Assessment System. And the building has 30% higher energy efficiency than the usual ASHRAE standards. ASHRAE standards means for American Society for Heating, Refrigeration, and Air Conditioning Engineers. So the typical ASHRAE standards building efficiency, here it exceeded by 30%. And thanks to the contribution also from the geosynthetics, that produce the heat gain and the cooling loads from the green roofs, from the green slopes, etc., and improving the thermal comfort and reducing the HVAC, the heating, ventilation, and air conditioning demands, improving overall the sustainability performance in the project. I would like to share my final reflections on the project with respect to the various scoring criteria in the competition. First, the relative importance of geosynthetics solution in the project. You have already seen how steep vegetated slopes were enabled in the project, and it's the most important aspect of the geosynthetic solution in the project, especially considering the arid region of the project. Without reinforcement and drainage layers, steep vegetated slopes simply wouldn't have been worked in Qatar's desert climate with along the conventional construction materials. Another aspect is that the geosynthetic systems, here forms the foundation of the world's largest green roof through performing functions such as filtration, drainage, and root zone stability. And this overall contributes to the structural and drainage stability of the support system. Also, the geosynthetics enabled the green roofs and walls actively contributed to 30% energy efficiency gain through actively reducing heat gain and cooling loads, directly supporting the energy efficiency compared to typical ASHRAE standards. Now, the innovative practices adopted in the project. The sustainable use of marginal desert soil or a dune sand was a key innovation in the project, overlooking the FHWA requirements for the structural soil, and this was made possible mainly through the effective drainage and waterproofing offered by the drainage geocomposite layer. Efficient management for irrigated landscape was another innovative practice by providing a geocomposite layer around the entire footprint as a waterproofing and drainage layer. It controlled the moisture retention and quick removal of excess water, which were critical in Doha's high evaporation climate to keep the vegetation healthy and to perform in the long term. Next is environmental and social benefits, which are briefed in this slide with reference to the various United Nations Sustainable Development Goals in terms of how they are contributed directly or indirectly. So the use of local materials, mainly the marginal dune sand, EPD certified geosynthetic elements, and the reduced earthwork contributed to SDGs 9, 12, and 13. Avoiding the use of cement or any cement-related products and the use of modular geosynthetics contributed to SDGs 12 and 13. As we saw earlier from the comparative LCA study results, the reduction in the environmental impacts contributed to the SDGs 12, 13, and 14 because the reduction are in the range of 73 to 37%. So that's about the environmental benefits. Coming to the social benefits, hosting tours and workshops at the Expo's House created public awareness of sustainable design, which indirectly contributed to SDG number 11. Also, you can see that upskilling of the local team in the green roof construction as well as geosynthetic installation contributed to SDG number 8. Finally, by adding a new community space in Al-Bada Park, permanence community, for future events contributed to SDG 11 and 13 by strengthening sustainable climate-friendly public areas. Concluding remarks. As a conclusion, I hope the next points presented shall capture the key takeaways from the Expo House project. The Expo House 2023 was established as a landmark in the arid region, challenging the arid site or changing into a long-term sustainability-focused public venue for future events. The green roof in the project acts as a living showcase of or a live demonstration of sustainable design and urban greening, educating the visitors visiting the Al-Bida Park. However, the project also highlighted how much untapped potential of geosynthetics still has in landscaping, especially for complex geometries and green infrastructure works. The Expo House 2023 clearly shows how sustainable geosynthetic solutions can deliver high-profile, technically demanding landscaping and architectural outcomes. So, ladies and gentlemen, that brings us to the end of the presentation. Thank you so much for your attention, and I am ready to take any questions that you may have.
Thank you very much, Jay. Judges, any question?
Angelo, am I in time?
So I have a question. So the vegetation on the top of the geosynthetic material, I think there's kind of changing cycle. Like after a certain number of years, you might need to change the vegetation. So how do you expect when you remove the current vegetation and leaving the geosynthetics exposed to ultraviolet light, how this will affect or cause damage for the geosynthetic material? And I would love to know what is the time or the time interval to change this vegetation.
Professor Mosse, that's a very good question. The client planted a varied species, a local species as plantations, and it had different design lives. But however, they planted the most easily available and most sustainable type of vegetation. Of course, it has a lifetime, which is in the range of 5 to 10 years for different types of species. However, the replacement is something that happens very quickly. So we are not expecting an exposure to the ultraviolet radiation because there is a full-time horticultural company available at the job site for the maintenance, because this is a place where visitors visit a lot on a daily basis. So every day it's properly maintained. The challenge is how to redo the vegetation, because we are talking about soft landscaping. We are not talking about a hard landscaping. So removing the vegetation and redoing it can sometimes damage the geosynthetic stabilized solution. So on the geocell system, it's more easy because you have geocells confinements. You can just remove. Sometimes the soil comes out and you have to replace it. But more challenging is on the steep slopes because any damage can affect it. So that's where they have been doing it carefully. But right now, since the project is completed in 2023, the first cycle of maintenance has not started yet. I'm telling this from my experience in Dubai, a similar project where we have done, which has already completed 5 years, and how they have, removed some of the species and replanted. We have seen how it is done. Now it is done very quickly. So a long-term exposure is not a question because there is a company full-time on the site. How to do it? There is a lot of tricks and methodology available that we also go to the job site and helps them without damaging the material. Thank you for that interesting question.
Thank you for the clear answer. Thank you.
Okay. Viviana?
Yes, thank you for the interesting presentation. I just have a similar kind of question about the durability of the geosynthetics that you used. So do you expect that the vegetation will last more or less than the geosynthetics?
Thank you, Viviana. So it's a continuation of the same answer. Compared with other countries in Middle East, when these kinds of iconic projects happens, like I said, there is always on board a horticultural company, a local landscaping company. They have a daily job to do the maintenance, which means you are not expecting a seasonal variation in the vegetation. Like in the natural vegetation growth during the rain time, there is vegetation, and afterwards it becomes dry and then the structure is exposed. No, this never happens here because all the vegetation is forced vegetation through a company. However, the design life of the structures are different. For example, a geocell is not expected to have a design life of more than 10 to 20 years, whereas the steep slopes has been designed for a design life of 100 years. So geocell, the client is very well expected the inner slopes, when it is exposed and there can be damages, they are expected to replace the inner slopes within a period of 10 to 20 years, which we really don't know. Once that reaches that period, they will know.
Thank you.
Thank you.
Very good. So thanks again, Jay, and for this nice example of sort of, how to say, tailor-made solution with a comprehensive application of all kind of geosynthetics. This happens when, let's say, with the manufacturer or the company also is becoming a reliable consultant, technical consultant, and not just supplier of material.
Absolutely.
So
absolutely.
You have been able to supply geomats, geogrids, drainage composite, geocells, non-woven geotextile. Very good, with a great contribution also to the sustainability of the project. But another point is that we usually look at geosynthetics to provide a structural solution. In this case, together with the structural solution, also it's possible to provide give the tools to the architects to provide creative architectural work. Very good.
Absolutely. Thank you.
Okay, next. Yusker company. Presenter is Matthew Awad, and the project is the case of the Pokwasa interchange in Ghana. Prego. Matthew. Share the screen. Very good. We cannot hear you. Very good. Now it's okay.
Yes, hi, can you hear me?
Now it's okay, thank you.
Perfect. And can you also see my screen?
Yes, yes.
Perfect.
Full screen, good. Go on.
All right, thank you. Okay, good afternoon, everyone. My name is Mathieu Awad, the area manager of the Middle East at IGS Synthetic, and I'm very happy to be here today to present the case study of the Bokwase interchange in Ghana. So the title of this case study is Sustainable, Cost-Efficient, and Rapid Construction of Urban Infrastructure Using Geosynthetic Reinforced MSC Walls. The project was carried out in cooperation with several local and international partners and stakeholders, including Admir Africa, the consultant, the contractor, and the local stakeholders. I would also like to welcome Mr. Max Nods, present with us also as well as project partner and manager. So my presentation will be structured in 10 small parts. First, I will start by introducing the project and the challenges of the project, as well as the limitations of the conventional systems. Then I will move on to introduce the geosynthetic solution, the MSC wall technology, focusing on the sustainability, performance, the economic efficiency, and the constructability. Then I will move into the impact and relevance of the project from an innovation and global relevance point of view to finally closing with the relevance importance. So the Bokwase interchange is located in the Greater Accra region in one of the fastest growing urban areas in West Africa. Accra has a very high pressure on its road infrastructure, and currently the public railway system is also limited, as well as the organized bus system. So a lot of the daily commute is being done using taxis, cars, and small vans. So this means there's a lot of congestion problem, which causes a major challenge for both mobility and economic activity. Therefore, to solve this issue, the Bokwase interchange was introduced as part of an important transport corridor connecting several major roads and highways. And due to the major complexity of the geometry, it also contains large retaining structures for the ramps and the approach embankments. So the Bokwase interchange was one of the first fourth-tier interchange with multiple bridge levels and connecting roads in West Africa. At the time of building, it was the largest interchange in West Africa. And there was also several key challenges during the project. First of all, the subsoil in the area is weak and compressible. So yeah, the solution needed to require a settlement tolerant solution for the retaining system. Second of all, the construction had to be carried out while keeping traffic moving as much as possible. Third of all, the project is in an urban area with limited footprint. And there was also a budget constraint for the project. So the solution for the retaining walls need to also be cost efficient. And last but not least was the seismic condition because of a geological fault zone. First regarding the conventional retaining systems that were considered. They included the cantilever wall, the gravity wall, and the deck on pile system. However, this system had clearly disadvantages. First of all, they would require more concrete and steel, meaning a higher embodied carbon. As we already discussed, we had weak soil for a subsoil. This would also mean deeper foundation and higher cost. Also, the conventional solution would require formwork, casting, curing, which also increase the construction time. And those rigid structure, they have problem. It's a stiff structure. So they are not tolerant to settlement and seismic effect compared to MSE walls. So for the Pokwase project, we needed a retaining system that is flexible, faster to build, and better suited to local ground and site conditions. Therefore, the solution of using geosynthetic reinforced MSE walls was chosen as a practical and innovative solution. MSE walls combine compacted soil and geogrid reinforcement into a stable composite structure. In the whole project, more than 20 to 25 MSE structures were built with heights up to approx 12 meters. And the high performance geogrids were tailored to site requirements. The system was designed following the Eurocode 7 and the British Standards 8006, and the internal, external, and global seismic stability were also verified. And an important technical advantage again of this solution was that it was a flexible solution allowing to accommodate differential settlement more than a rigid concrete wall. Now to discuss about the sustainability performance of the solution. So this sustainability came from several sources. First of all, the MSE solution reduced the lower embodied carbon. This was achieved due to the reduction in concrete and steel, which are main components of conventional retaining systems. And this also meant that lower overall material use was achieved by using MSE walls. Second of all, the system allowed to use locally available sand. So the original design was made using imported backfill with a frictional angle of 35 degrees. However, the contractor wanted to use the available local fill. So then laboratory testing was done, and then the design, we redid the design in order to be able to use the local fill for the backfill. And this, of course, achieved two important benefits. First of all, it reduced the pressure on natural resources, and it also reduced the need of transporting large volumes of quality fill from far places, and of course, it also reduced the total cost of the project. And talking about sustainability, we also have the long-term resilience. So this solution performs well under seismic loading. It has a long service life, also meaning a low life cycle maintenance. Regarding economic efficiency, the MSE wall provides lower construction cost, as we can see in the graph on the right, with the cost being typically around 70 to 75% of the cost for a conventional concrete ring wall. This lower construction cost is due to the reduction in material quantities, simpler foundation requirements, the local material use, the faster installation, and the lower maintenance. Regarding the constructability and the construction speed, it's a very relative and simple and efficient. We placed the backfill, we compact it, we install the geogrid layer based on the design height, and then we finish with the facing. We don't have any curing delay. It's a continuous progress with reduced destruction also for the local society. Here we can see a picture during the installation of the facing. Yeah, this project was definitely innovative because it introduced the MSE wall design in a large scale in Ghana. There had been previously MSE walls in Accra, but this is a first major application in such a big scale project. It was done in cooperation with several stakeholders, and the training also was very important and practical. It was not only classroom training, it was on-site training, how to place the geogrid, how to backfill near the wall, and how to maintain the quality during each layer. And this is one of the very important takeaway message and goal of this project, because this knowledge transfer can now be used for other projects in Ghana and West Africa. It also was awarded the FIDIC recognition for engineering excellence due to innovation, and the MSE walls were definitely part of this innovation. And this project is highly transferable to other projects and other countries. Growing cities have the same challenges, from high transport demand, limited space, weak subsoil, budget pressure, and local resources. And the MSE walls were very well suited to these conditions. And I would say that the Pukwase is a reference model, not the one of exception. To conclude, the Pukwase interchange clearly demonstrates the benefits of geosynthetic reinforced MSE walls. The system successfully addressed the main project challenges, from weak soils to settlement sensitivity, to limited urban space, traffic disruption, and budget pressure. It also supported the social local community, as well as it created a knowledge transfer for the whole region of Ghana and West Africa. So geosynthetic are not an alternative material, they are a key enabler of sustainable, cost-efficient, and resilient infrastructure. Thank you for your attention.
Thank you very much, Matthew. Very good presentation. Any question? No question, even not from the attendants.
I have one question.
Okay.
Angelo. Under the social point of view, what is the most important and effective effect of your intervention, you think?
Yeah. So first of all, I would say that the interchange is located in an area that is already contains it's close to trading and shops. It also close to buildings, residential buildings. So it was very important to have a small footprint for the whole project. And secondly, the fast construction. So to have being able to do the whole construction while not disturbing the traffic and not closing while not disturbing the traffic was also very important for the daily commute of the people passing into this region.
Okay, and just the last question and curiosity, actually, have you also made quantification of the benefits that you get with this geosynthetic solution under sustainability point of view? So have you quantified the emissions that you earned with this solution, or is just a qualitative assessment that you did?
No, it was a qualitative assessment, but I mean, one thing is sure, we were able to use the local fill instead of importing backfill from a far region. So this is one thing. But it was a qualitative, not a quantitative assessment.
Thank you very much for your interesting presentation. Thank you.
Charles?
Thank you, Mathieu. Very interesting presentation. I just wanted to know from your point of view, what stands out as the most innovative part of the design and project?
Mm-hmm. Yeah. For me, what was very interesting is that, as I mentioned, the first design was using a backfill of a higher, a premium or excellent backfill with a angle of friction of 35 degrees, and being able to switch from this highly engineered backfill to the local fill in order to save cost and being more sustainable. This is very important to have this flexibility using geosynthetics, and also, of course, being able to have a system that is flexible on settlements and on the seismic effects. This is also very very important if you compare it to any other conventional method.
Thank you.
Max?
Maybe I can add to this because I was directly involved also in this project. One of the challenges which we were facing already at the start of the project is that the original MSE design was asking for full height panels. At the same time, there were high voltage electricity lines in the sky, so that would create a danger installing the full height panels. So on the job, we had to change the design together with the contractor to small segmental panels, and that's what we did. And eventually, together with the Chinese contractor, we came up with a very clever solution of vertical bars and horizontal bars with a slot where standardized sizes of small concrete panels could be sliding from the top down into in between these vertical bars. And that turned out to be a very interesting innovation and also a very fast construction method for the panel solution. At the same time, not creating any direct contact between the facing element and the MSE structure. So I would say that was also a very interesting innovation. Thank you.
Thank you very much, Max. And I want to take this opportunity to thank Max Nods for the promotion that, of course, he has made for USCARE and for Admir Africa, probably for the last 15 years, or probably even more, in Africa and especially in East Africa. And this is a promotion for the whole industry because, for example, this project in Ghana is a good example of application of geosynthetic solutions, a reference model, as Matthew was saying. And this is a reference model for all these emerging countries like Nigeria, like Ghana, and many other countries, where with the construction of this MSCW, we can show all the advantages of the geosynthetic solution versus the traditional solution in terms of sustainability, cost effective, cost reduction, speed of construction, limitation to traffic congestion constraint, for example, also. So thanks to Matthew, thanks to Max for the great work that he has been doing for all the industry in this part of the world. And now from West Africa, we go to East Africa. We go in Mozambique together with TechFab India, and the presenter is Manish Bharat, and the project name is a case study on ground improvement for container yard and storage warehouse at Nacala port in Mozambique. Manish, prego, share your presentation, your video.
Yeah, please. Thank you very much, everyone, to give me an opportunity to present the case study of Mozambique. I will share my screen.
Full video?
No, I have a presentation.
Perfect.
Can you see? Able to see?
Perfect. Go on.
Yeah. So, welcome to everyone. Today I am going to present the case study on ground improvement for container yard and storage warehouse at Nakalaka Port, Mozambique. So, just to give the brief about the project location is a Nacala Port. This project was executed at Nacala Port in Mozambique, one of the deepest natural ports on the East African coast, and a strategically very important logistic hub for the regional and international trade. With the increasing cargo volumes and growing port activities, there was a need to develop a new container yard and storage warehouse facility capable of supporting the intensive logistic operations. So it's a very important, one of the deepest natural ports, strategic gateway of international trade and expansion required to accommodate the increased cargo volumes. So the infrastructure is going to develop on that site is container yard, storage warehouses, and heavy duty payment infrastructures. So demands of the project is like a containers taking loads, reach takers, movement of a heavy forklifts, heavy truck movements, and continuous operational traffic, which are the objectives for these actually to high bearing capacity required, long-term serviceability required, minimal maintenance, and we have to control the settlement also, as there is a site near the actually seashore. So you can say the marine clay has a very big problem. So geologically, the characteristic of the project site soil is like a loose to medium dense reclamation sand, underlying soft clay deposits. Groundwater is also shallow at the shallow groundwater table, low shear strength soil, moderate to high compressibility. So you can see the site photograph. We have done the number of trial pits, and we come to understand that the soil is very soft, groundwater table is very high, and we have to take care of the heavy loading, then high settlement. We have to control the settlement, as well as we have to reduce the foundation stability, and deformation also we have to reduce. So as already discussed, the existing ground condition is very difficult for, you can see either we have to go for the replacement of soil or any deep foundation things. So we have a various, you can say conventional solution by the means we can go, but the area is around 65,000 square meter. So other solution is going to be costly, as well as if we go for a replacement, then a large volume of good soil or good aggregates availability is far away from the site, and it will require more actually cost implication also. So you can see the key challenges here is a weak subgrade soil, excessive settlement risk, heavy operational loading, high groundwater condition, and durable payment performance we require. So conventional approach, I was already told that deep excavation, soil replacement, or the thick granular layers. So the drawback of the conventional solution like high cost, longer construction time, increased material consumption, and larger environmental footprint. So a technically reliable and sustainable ground development solution we are looking for. The client is also looking for such. So these are the warehouse layout with the geocell system we have suggested, which will improve the bearing capacity, enhance the load distribution in a larger area. Then it will reduce the settlement, increase the foundation stiffness, support repetitive heavy loading, and minimize the maintenance. So Texel geocell we have suggested, which is a three-dimensional confinement system, which will give the reinforcement mattress effect, improve the load distribution in a larger area, and enhance the subgrade performance. So why geocell? It's a technically sound and proven, and it is also economical compared to the conventional solution where a large volume of aggregate needs to be used, or a deep excavation should be used, or soil replacement should be used. So, and it is a sustainable solution and very easy and fast to construct. So, as you know, all geocell working mechanism, the load is actually, when the load is applied to the ground, then it comes without, if you are going for a without geocell reinforcement, then the stress condition is it always like the, it will come in outer form, outer way. So settlements corresponding to total bearing pressure is more if in such this type of soils, where the soft soils or a CBR 2 or 3 value of soil, very low CBR value soils. So with geocell, it will minimize the bearing pressure due to geocell reinforcement and reduce the settlement corresponding to minimize bearing pressure. So load distribution in the field geocell is good, and friction between cell walls and initial will give the stiffness to the actually platform. So the proposed design section is like existing weak soil is the foundation, then 170 mm filling G5 material with the textile geocell. So 150 mm thick geocell we have used, and above that 20 mm more we have used the geogrid. So it will not actually damage the edge of geocell. Then above that there is a cementized stabilized G5 base of 200 mm and 35 MPa capacity paver block of concrete, interlock concrete paver block is used. So key benefit of this solution: enhanced load distribution and confinement, reduced settlement potential, high bearing capacity, and durable and long-term solution. So these are the photographs of the site. Yeah, first of all, we have to do the site preparation. We just do the rolling compaction of the existing soil, then deployment of the geocell in line and level as per the requirement, then infill gun placement, then compaction of the layer filled with geocell, then base layer construction and paver installation. So these are the execution methodology, and after that we will quality control. So these are some of the photographs during the execution. It's a very large area of 65,000 square meter area. So we have tried to use the infill material from the nearby sources, so can give the sustainability benefit. So environmental and social benefits, again, reduce aggregate consumption with the geocell. If we are going without geocell, the thickness of aggregate layer may come around 500 to 600 mm or more. So here we are achieved with the 170 mm geocell field. Then also, as we are not going for any deep excavation and we are laying directly on the existing soil, the deep excavation is reduced, the reduce of excavation, and also the disposal of the same material. Then reduce the transportation required. As this material required, the less or lower fuel use for emissions of the aggregate material. And it contributes to a significant CO2 reduction and climate responsibility. So as per just, I have calculated for small 25 year of design life with a CBR 3% for the project area. So we are saving in almost 41% of the aggregate Then truck trips reduce 1706. So indirect benefit of CO2 reduction for these trips actually of 500 tons CO2.
We
And
cannot
reduce
see,
the carbon.
sorry, Manish, we cannot see your
Yeah.
screen now. It's dark. Okay, now.
You
Yes.
can?
Now it's okay. No. Yes.
Yeah, fine.
Go to next.
Yeah.
Okay,
So
now it's okay.
as a sustainability dashboard, I just calculated for some of the data. So we can save the aggregate, we have saved aggregate around 34 tons, which will reduce the trip of actually 1700 tons, which will give the direct CO2 reduction of 500 tons, and also the reduced storing and natural resource consumption. So this is the sustainability dashboard. So outcomes and conclusion that we have enhanced the bearing capacity required for this important project of the actually port, and completed the work in a very timely manner. Then improve the load distribution, reduce settlement potential, and also we have provided the heavy duty pavement application, and it's a cost-effective solution. So the textile geocell reinforced foundation system successfully transformed the weak coastal soil into a stable platform capable of supporting a heavy port operations, demonstrating an innovative sustainability and technically robust solution for a critical infrastructure development. So why this project is a benchmark for the Africa and Middle East region? This project demonstrates a proven, innovative, and sustainable ground improvement solutions that delivers high performance in challenging ground conditions across the region. So in coming days, the other ports, logistic parks, container yards, industrial platforms, warehouse, we can definitely go with this type of solution. So it's a smarter, greener, and stronger foundation for infrastructure development across Africa and Middle East. So thank you very much.
Thank you, Manish.
Yeah.
Thanks for the nice presentation. So, any question? Mohammed, please.
So thank you for the presentation. I have like a question. Did you do like a loading test on the platform after construction? And if so, what was the settlement and how long was the test?
Sir, actually, no, we have not conducted because we have just handed over to the client after that. And the consultant is of the local consultant. So we have actually, we have not got any complaint or anything about it. And yeah, but we can do the analysis. But yeah, we, as per our calculation, the settlement is under the control, and we have not tested afterwards.
Yes, but what is the expected settlement even based on the design calculations, considering the long-term settlement of the deep or the soft clay deposit underneath the
So
sand?
actually, long-term settlement is in the range of the below 100 mm.
Yes. Yeah. Okay, so thank you for your answer and thank you for the presentation.
Okay,
Yeah.
Viviana.
For the nice presentation, I have one question about the time period during which the project was realized, which was not clear to me.
It is actually the project is started in November 23 and it's completed in around May 2024 or like that. And in the second phase on 2025 also we have supplied the material for the other area of that same.
Okay, thank you. And also the second question is, you quantified the reduction of CO2 emissions using the geosynthetic solution, but you compared with which classical solution your results?
Yeah, we have just used the conventional solution of aggregate replacement of around 600 mm thick.
So the replacement
layer.
of the foundation.
600 mm.
Okay, thank you. Thank you very much.
Roy and Max, I don't know if you can make questions since you are part of the game. I asked John. John, how is the rule? Because already before
but it's true because I also have a question during their presentation, but I have kept mum because we cannot ask.
I think best not to. Best, I think that would be the even-handed approach.
Yeah. Very good. So, Manish,
Charles
thanks
has a question.
Yeah, you have a question, Charles? Yeah.
Yeah, just a quick one. I just wanted to ask if there were any considerations in drainage
Yes.
of your base. Yeah.
Yes. Yeah, we have done the side drain as well as we have subsurface drain. I have a cross section, but I have not put as. But yeah, we have a consideration of drainage because it's a. Can I show you quickly the cross section? Just.
Okay, so we have seen geosynthetic solution mostly with MSc application. This one was for ground improvement. We are used to see geogrids, integral geogrids for this kind of application. But this is the typical case that when a good soil aggregate is not available, geocells can become the solution to provide a performing solution where poor soil with a very low bearing capacity. And again, the common the common benefits that we can see from all the application is how.
Can you see the screen? Can you see the screen, Mike? Screen?
Yeah, now yes.
Yeah, so we have also given the subsurface drain.
Just you want to give more details, yes?
Yeah. So there is a geocell, and that below that we have crushed rock subsurface material, and below that there is a gravel layer wrapped with again the geotextile.
Okay.
Yeah.
I think that's okay. So I was saying that we've seen as all the geosynthetics in a different application. At the end, they provide innovative solutions, sustainable and cost-effective solutions. Thanks to everybody for giving your presentation, to the attendants. And now the procedure is that the judges will make a separate meeting to decide who is going to be the winner and who is going to participate to the final in Montreal next September. In the meantime, the organizer of IGS Africa will give a presentation about the next conference in Africa.
Angelo, if I can just say, so to the judges, please go to the Teams link I shared with you. We'll have to leave this meeting, obviously, and we'll come back into it. But the Teams link is the place for us to just make sure we've got your scores. So we're going to leave the meeting and we'll be back in a few minutes. Thank you.
Thank you. Thank you very much. Thank you, everyone.
So even we are going to leave. John?
Can we leave?
No, I say
judges.
Yes, the judges will leave. We remain in the GeoAfrica. Okay. Who is going to give the presentation from GeoAfrica? Tyron Naidu.
Hi, everyone. I think you can see my screen.
Good morning.
Hi. Hope you guys are well. Can you see my screen clearly?
Yes, we can see. Very nice.
Lovely. I hope you can't see my notes. It's been ages since I've used Zoom, so excuse me. All right. Okay, guys, if you didn't know, GeoAfrica is making its way back to South Africa in March 2027, hosted by the IGS South Africa under the guidance of the International Geosynthetics Society. We are genuinely excited to welcome this event back to our shores, and would like to extend a special invitation to everyone on screen, as well as your colleagues out there. Across the Middle East, we want you to come into Africa, share your ideas, exchange your knowledge, and with any luck, take a few good ideas home with you as well. But before I get too serious with this little presentation that I have, we should probably acknowledge that South Africa's football performance may not always work in our favor. Fortunately, we are far more confident in our ability to host a geosynthetics conference than we are in predicting a football result. But we can debate the scoreline properly when we see you in person next year. So save the date for March 2027. GeoAfrica always brings together the people, ideas, and technologies shaping the future of geosynthetics across the continent. Come join industry leaders, engineers, and innovators as we connect, collaborate, and develop smarter solutions for not only Africa, but the world over. Come for the conference, stay for the conversation, and leave with some good ideas as well. We would love to welcome you to our beautiful and vibrant country in March next year for a little sunshine, plenty of good conversation, and most importantly, the opportunity to connect over the ideas shaping the future of geosynthetics in the built environment. GeoAfrica will be hosted at the Misty Hills Country Hotel, Conference Center and Spa in Mildersdrift. That's just on the outskirts of Gauteng, Johannesburg. Set among more than 60 acres of lush botanical gardens, the venue offers a peaceful, perfect balance between a professional conference setting and a distinctly African escape. Expect insightful presentations, meaningful discussions, great food, I can vouch for that, and the chance to reconnect with old friends while making new ones. The program will bring together practical experience, technical insight, and forward-thinking ideas from across the geosynthetics industry. Topics will range from roads, railways, mining, and environmental applications, just to name a few. The program will also explore the growing role of geosynthetics in sustainability, carbon reduction, and climate-resilient infrastructure. With a strong focus on case studies and recent research, the conference will create a space for meaningful discussions, shared lessons, and solutions that can be applied onto the ground. Ahead of GeoAfrica 2027, the Geosynthetics Conference for Young Professionals, known as GCYP, will bring together the next generation of engineers, researchers, and industry professionals. It is a space for young professionals to meet, share ideas, present their work, and learn from others who are on the same journey as them. More importantly, it is an opportunity to take the conversation forward and help shape the future of geosynthetics in Africa and abroad. Young minds, shared ideas, and the next chapter of geosynthetics. GeoAfrica will offer a full week of technical sessions, workshops, exhibitions, and industry discussions, balanced with opportunities to relax, reconnect, and enjoy the true spirit of South African hospitality. The program concludes with a carefully planned technical tour. We are taking the time to ensure that this is more than just a site visit. It will be an opportunity to see where design meets reality, where technical thinking becomes built infrastructure, and where practical lessons can be taken back into future projects. The call for abstracts for GeoAfrica 2027 is open, but the clock is kind of ticking. Abstract submissions close on the 30th of June 2026, so now is the time to share your research, case study, or practical experience with the geosynthetics community. There may be an extension. Conferences seem to enjoy deadline extensions almost as much as contractors enjoy variation orders. But please do not treat this as a confirm. Start writing, submit early, and save the last-minute panic for absolutely something else. We are calling on sponsors to join us in making this event one to remember. It is a great opportunity to place your brand at the center of the conversation, support the geosynthetics community, and be part of an event bringing together ideas, innovation, and people from across Africa and beyond. And let's be honest, good conferences need good sponsors. The coffee doesn't pay for itself. Sign up to our newsletter, follow us on social media, and stand a chance to win free conference registration. It is a simple way to stay updated, following the journey, and possibly secure your seat at GeoAfrica before the conference even begins. Because while geosynthetics may be technical, winning a free registration is refreshingly straightforward. So follow us, sign up, Stay informed, and you may just be our next winner. There's plenty happening on the road to GeoAfrica 2027, and the easiest way to stay updated is to follow us, follow our journey. Use the QR codes to sign up for the newsletter, follow our social media pages, visit the website, submit an abstract, or explore sponsorship opportunities. Whether you are planning to present, sponsor, attend, or simply keep an eye on what is coming next, all the information is only one quick scan away. And of course, following the updates may also place you in line for a free registration, which is always a good way to start the conference. Thank you to the organizer of this event from the GeoAfrica team in South Africa, and we look forward to seeing you in our lovely country next year. Thank you.
Thanks to you, Tyron, for this nice presentation. I think that everybody is already trying to scan to get the free participation.
Yeah.
Very good idea. Very good idea. Yeah. Okay. So let's see if the judges have taken a decision, if they come back. Of course, before Johannesburg, there is Montreal in September, where we wish to welcome all the participants.
Yes. We look forward to being at that one.
Yeah. Okay. Let's see how it's moving. Anyway, it's good to see how much potential there is in Africa. Let's say Middle East is very well known. I'm in this world already since 35 years, even if I don't show up that I'm so old. But
it's not showing, I can tell you that.
And Middle East is already almost a major market. Africa is still there to discover, and is so big and so much potential for everybody. Yeah. So
thank you.
Max, what do you want to say? You are the main expert for the African market, apart from South Africa, let's say.
No, that's not true. That's not true, Angelo.
Also South Africa.
I'm working in Nigeria, in Ghana, in Kenya, and Uganda. Those are the focus markets.
Okay.
So and the other markets are completely blank for me, really.
Yeah. No, but already.
Yeah.
Big countries already.
And
also challenging. I mean, Ghana is it's okay, but Nigeria, eventually everybody's looking a little bit scared to Nigeria.
Yeah. Well, the security issue is manageable, as we call it. You shouldn't go there and rent a taxi at the airport and start driving, because I would not recommend that to anyone. But you have to organize your security. That's clear.
Yeah, of course.
And Ghana, the major challenge over the last couple of years was the budget constraints, because the governments were on a very tight control by the World Bank and the IMF because of overspending, and therefore the major infrastructural works had all come to sort of a stop, and now bit by bit it is opening up again. So that's a good sign. So every local market has its own specific challenges. Let me put it like that. That is how I experienced it in those 4 markets. And I have to say that I'm absolutely a nitwit in all the other markets in Africa, really.
Okay.
Yeah.
Yeah, other good markets for sure are Morocco, Egypt. Egypt also, since I started with Tenax more than 35 years ago, Egypt was already, I remember we were in Atlanta in 1996 or 1998 probably. And we provided the reward as best distributors Geos, Nigeria, that was our distributor in Egypt. So also Egypt is still performing very well for geosynthetics. Let's say all the retaining walls are made with geogrids more than just with concrete.
Maybe I can make one general remark because it applies to everyone. A major challenge which I see, and probably in other markets as well, is the very, very high import duty rates on geosynthetics. And despite of these very high rates, we can still make solutions feasible, economically feasible. But it could be so much better if we reach a situation where these import duties are, let's say, more acceptable. Okay, so I experience that as a major challenge. I don't know how others see it, but maybe the IGS can do some lobby work there.
Yeah, this is a good remarks. But this is because I mean there are not local manufacturers that, for example, like in India or even in Europe now there is some trial to apply duties to product coming from China, from India. But in those countries that there are no manufacturers, so at the end are just the concrete producer or just mining or what? From where these kind of duties are coming?
The country duties, import duties.
Just import duty. Even if they are like in Ghana, I mean, they have constraints in terms of budget. They should understand that geogrids can help.
Yes.
Yeah,
yes. Of course, sometimes there are projects which have a tax exempt, no, because of international importance. But those are more the exceptions to the rule. So typically, you face very high import duties, where the geosynthetic contribution to the overall cost of a structure becomes larger. Of course, that is playing a larger role, and that could create a situation that the financial contribution of a geosynthetic into a total solution becomes larger than in European or American markets.
Then it's very tough to fight against traditional solutions.
Yeah.
I see our judges that are back. Who is going to nominate the winner among you? Who will have this role?
Hi, Angelo. I'm about to text you the result in the chat.
Sorry, who is? Yeah, I see they are back. I mean,
I think
who of them is going to? Viviana?
I think it will be you, Angelo.
Oh, I didn't see the email.
So, Angelo, you'll have a message in the chat.
Okay, now I can see it. Okay, thank you. So I am happy to say that the winner is Jay from Macaferri. Congratulations. I don't know if any of the judges wants to give a comment to the reason of this result. Viviana, can you open the microphone? What was the discussion? What was the the main reason?
We actually all agreed about the impact of the project and the way also the sustainability aspects were accounted for, and I mean all the also social impact and innovation. Also, the project was presented during the presentation. So, congratulations, Jay, for your presentation.
Congratulations, Jay. Congratulations, Jay. Thank you so much. Can I say a word?
Yes, I mean, I want to
just wait if Mohammed and Charles probably wants to add something.
Okay.
Yes, I just wanted to conclude saying that all the presentations were of very good level, and I want to say congratulations to all of you, because all the projects were very, very interesting and innovative in a way. So thank you all for your participation and for the presentations.
Mohammed, anything to say? Any
So
comment?
yeah, so I would like to congratulate Jay and for McAfee. All the 4 presentations were excellent. The presentation offered by McAfee, it showed how geosynthetics can be used in a highly sustainable solutions, like turning part of the desert into green area and vegetation, which is an important aspect for geosynthetics besides solving the soil problems, either settlement or low bearing pressures or containment in environmental applications. So congratulations, and we would love to see more projects like this. Thank you.
Thank you. So, Jay, what do you want to... I know, Charles.
Yeah, just thanks. I just wanted to repeat what Viviana said and Mohammed, that we were all unanimous and we were very impressed by the sustainability aspects of the McAfee project, as well as the innovation and the many different types of geosynthetics that were used in that. So well done, Jay. Thank you.
Please,
Thank you
Jay.
so much. Thank you so much. I just want to say thank you, the IGS, the judges, all the participants, and everyone who are here today. I must also place on record my gratitude to McAfee, as well as my colleagues in McAfee Middle East who realized this project. And we are keep pushing the geosynthetic innovation for the advancement of our industry. That's what I can say. Thank you, everyone.
So it will be nice to see in...
Thank you.
It will be nice to see in Montreal this fighting between McAfee Middle East and McAfee Asia.
McAfee Asia, absolutely.
Anyway, thanks to everybody for attending. Thanks to the corporate members for making this work. And I hope that in the coming years also we will get more and more case study from all the manufacturers. It is important to understand that this is a part of the marketing. This is a part of the way to get geosynthetic solutions more and more accepted versus traditional solutions. But we need the participation. We need all the corporate members to be more and more active in this. Thanks to everybody.
Thank you. Have a good day.
For your time, and thanks for participating in this event. See you in Montreal.
Thank you.
Thank you.
Thank you all. Well done.
Thank you.